Okay, I have decided that I am going to go through the review by video this time, which I haven't done in the past. So let's see how it goes. Hopefully you have already done your review and you are just checking your answers rather than just trying to do everything from start to finish right now. That is the ultimate goal, for you to have tried it first, see what you know, see what you don't know, and then we go from there. Okay, number one. This is a proportion, so we cross multiply. So I multiply this diagonal, and I multiply this diagonal. And so that's what this step here is about. And then after that, you distribute. So you have to distribute your 8. 8 times 2x, 8 times negative 1. You have to distribute your 4. 4 times x, 4 times 1. If you ever have x's on opposite sides of the equals, you have to move one of them. I like to move the smaller one, so I subtracted 4x from both sides. Once I get down to only one x, I circle everything smushed with it. I add or subtract whatever's outside the circle. And then I undo my multiplication with division. And x equals 1 is the answer you should get. Okay, so those are proportions. Whenever you have one fraction equaling a second fraction, and you just cross multiply. You just have to remember to put your parentheses around the 2x minus 1 and the parentheses around the x plus 1. That way the 8 distributes and the 4 distributes. Okay, I'm going to go over to number 3. Number 3 is a literal equation solving for k. So I circle everything smushed with my k. I add or subtract whatever's outside the circle. You can't actually add the g and the 5p, so I just recopy g plus 5p. If anybody put 5p plus g, that would be fine. And then I undo multiplication with division, so I divide both sides by 2. And then I wrote it in pieces, g over 2 plus 5p over 2. You could have these flip-flopped. This could be 5p over 2 plus g over 2. And since neither of these pieces reduced, you could have left the answer like this if you wanted to. G plus 5p all over 2. So the rules for solving equations are no different when we've got lots of letters. Circle everything smushed with what you're solving for, add or subtract whatever's outside the circle, undo multiplication with division. Okay, going down to number 2. Number 2, I had several things going on. I could combine like terms on the left side, negative 6 and negative 9 combined to be negative 15. On the right side, I distributed my negative, which made a negative 4x plus 5. When x's are on opposite sides of the equals, we have to move one, so I moved my smaller one. I moved my negative 4x plus by adding 4x to both sides. You could have done something different there. Once I only have one x, I circle everything smushed with it. I add or subtract whatever's outside the circle. So I get rid of my minus 15 by adding. You get 7x is 20. When you undo your multiplication with division, you can't actually divide 20 by 7. You can't reduce 20 over 7. So I just leave it 20 over 7. If you feel inclined to give me a decimal, you could do that. And if you gave me a decimal, it doesn't come out pretty, but it's about 2.9. So I'll go ahead and put that in there, or approximately 2.9. That's me rounding because it was 2.857 something, something, something. Okay, moving on to number 4 over here. I'm solving for g, so I circle everything smushed with it. I get rid of my minus 1 by adding 1. And then remember to get rid of a fraction. We multiply by its reciprocal, and I have to multiply both sides by the reciprocal. And then I just pop my negative 6 over 1. I multiply straight across, straight across. I get negative 30 over 4. And if I divide both of those numbers by 2, I get negative 15 over 2. And over here, remember this just makes 20 over 20, and 20 over 20 is 1, so that's why it goes away. Okay, heading down to number 5. This one we wanted to graph. So if I want to graph it, I want to make sure that it is in slope-intercept form. I want it to look like this, y equals mx plus b. So I circle everything smushed with my y. I get rid of whatever's outside the circle by adding or subtracting, so I subtract the 2x. I can't actually subtract these, so I just recopy the minus 2x, then the plus 10. I undo my multiplication with division, so I divide both sides by negative 5. Remember, the negative divided by the negative here makes a positive 2/5, and the positive 10 divided by negative 5 makes a negative 2. Slope's the number in front of the x, so my slope's 2/5. My y-intercept's the number behind the x, so my y-intercept's a negative 2. Whenever you're graphing diagonal lines, and I know this is a diagonal line because of the x and y, we always plot which one first? We always plot the y-intercept first. Think of b as begin. So the first thing I did was I plotted my y-intercept of negative 2. Y-intercepts are always on the y-axis. And then my slope is 2/5. So slope is rise over run. So I go up 2, right 5. Up 2, right 5. Or I can go reverse and go down 2, left 5. Number 6 wanted me to label 4 points directly on the graph, so that's what I did. I just labeled these 4 points. I wrote down what their ordered pairs were. Now the other day in class, I showed you some calculator tricks. So once we get our equation in slope-intercept form, we can have our calculator help us graph. So I'm just going to do that for you real quick, just so you can see it one more time. Of course, if you don't have the graphing calculator at home, you're not able to do this, but you could do it on test day. Okay, so I go to my y equals button, and I'm going to clear that equation. Remember, I always put my fractions in parentheses, so 2/5 x minus 2. Once I get it in my calculator, I hit graph, and I can see that those look pretty much the same. But in order to draw an accurate graph, all I have to do are see what points to plot. So I want to go to my table, so I go second graph, and I pull up my table. Of course, I see a whole bunch of negatives here, so I'm going to arrow down. And I start seeing some other things I could plot. So here's 0, negative 2, which was right here. Here's my 5, 0, which was right here. So you can find real nice points to plot from the table. Here's 10, 2, which was this one that I plotted. But in order to use the calculator for graphing, you have to be able to solve for y. So number 5, you would have had to have solved this for y. Put it in slope-intercept form yourself. Okay, number 7, it says, what is the 0 for the function for number 5? When you see this word, what is the 0? What is it really asking for? It wants to know what's the x-intercept. And remember, x-intercepts are where the graph touches the x-axis. So this guy right here is my x-intercept, because that's where the graph touches the x-axis, which is also called the 0. So the ordered pair 5, 0 is the answer to that question. Okay, moving on to number 8. Number 8 wants to know the slope of this equation. So if I want to know my slope, I want to put my equation in slope-intercept form, y equals mx plus b. That way my slope will be the number in front of the x. So that's what I did. I circled everything smushed with my y. I subtract the 2x. I undo my multiplication with division, and then I reduce my pieces. A negative 2 over a negative 5 makes a positive 2/5. 15 over negative 5 makes negative 3. And remember, your slope is the number that's smushed with the x, so my slope is 2/5. So if the equation's already in slope-intercept form, all you have to do is see what's smushed with the x. If your equation is not in slope-intercept form, you need to get it that way, and then it's the number smushed with the x. So this is a very important skill. being able to put an equation in slope-intercept form. Hopefully you're feeling pretty good about how to do that now. Okay, these next ones are asking us to write an equation of a line. Remember, that's when we either start with point-slope form or slope-intercept form. So what do you see that I give you on 9 and 10? You're given points. So if you're ever given points, we want to start with point-slope form. Okay, so whenever you're asked to write an equation, you need to decide, do I start with point-slope or do I start with slope-intercept? If you're given points, you start with point-slope. Then you have to ask yourself, do I have everything that the name says? Do I have points? Yes. Do I have slope? No. So that's the first thing you would have to find on number 9 and number 10. You'd have to find the slope between those 2 points using this formula. y2 minus y1 over x2 minus x1. And then once you find your slope, then you'll have points, you'll have your slope, and then you'll put your information that you found into point-slope form. So you'll find your slope, and then you'll pick the point you want to use, and then you put it in point-slope form. So let me show you how number 9 worked out. So number 9, I found my slope. I took y2 minus y1 over x2 minus x1. I got my slope to be -1. Then I picked the point I want to use. I decided to use the one -6, and I put it in point-slope form. So I go y minus the -6, which makes a plus, equals our slope -1, times x minus the x-coordinate, which is 1. The next thing I have to do is distribute my -1. And then to get y by itself, I have to move my +6 by subtracting. And I end up with y equals -x minus 5. And this is my answer in slope-intercept form. Now, I do want you to be able to do this by hand. It is my ultimate goal. Your brain power is essential. I'm just going to show you real quickly how to do it on the calculator. Just so if you needed to check yourself, you could. And just to know also. Whenever you want to write an equation with the calculator, we go to the button that says Stat. So if you want the calculator to write an equation, we go to Stat. I want to put in my information, so I'm going to Edit. And I'm just going to type over these 2 numbers, or I could delete them. List 1 are for the x's. So my x's are the -9 and the +1. The y-coordinate that goes with the -9 is a 4, and the y-coordinate that goes with the 1 is -6. And then I go to Stat again. I right arrow over to Calculate. I want to write the equation of the line, so I'm going to go to number 4. I hit enter one more time. It shows me that my a, which is the slope, is -1, which is what I found here. I just didn't write the -1, but you can. And the y-intercept is -5, which is what we found. Okay, number 10. I start off the same way. I start off by finding my slope. I take y2 minus y1 over x2 minus x1, and I get a slope of 0. Whenever 0 is on top, the slope is 0. Well, I can continue on, or in my brain I go ree-oo, ree-oo, ree-oo. Whenever your slope is 0 or undefined, I just stop what I'm doing. I think about what the line looks like. If the slope of the line is 0, it is a horizontal line. I know horizontal lines only have one letter in their equation, so I come over here and I look to see, and I notice that both of these ordered pairs have a y-coordinate of 9, so I know my answer is y equals 9. But I could have done it like number 10. I could have picked the point I wanted to use. I could have put it in slope-intercept form and continued on. But if the slope was undefined, I couldn't pick a point and put it in point-slope form. I couldn't work it out. So if I ever get the slope to be 0 or undefined, I just stop what I'm doing. I think about what the line looks like. I know there's only going to be one letter in the equation when the slope's 0 or undefined. So I just look at my ordered pairs. I see what they both have in common, and I just write that down. Okay. In this problem, it tells us that the slope of the line passing through these points is 5. And then it just says to write the point slope equation of the line going through the point -3, 6. So here's my point slope formula. And I just go y minus the y coordinate equals the slope they gave me, which was 5, and then x minus the x coordinate. And I stop. I stop right there. That's point slope. I don't need to keep going. If it says slope intercept, I'll distribute the 5. But since it says point slope, I'm done. Next problem, just like it. It wants the point slope equation of the line passing through -5, -4. So it's y minus the y coordinate equals slope of 5 again, x minus the x coordinate. 13 wants to know, will these equations give you the same slope-intercept equation, and why? Well, I wouldn't know officially unless I distributed and added the 6, distributed and subtracted the 4, but these will give me the same equation if I put them in slope-intercept form. And that's because the line is going through both points, and so they have to be the same equation. But if you wanted to prove it to yourself, you could actually work this out, work this one out, add the 6, subtract the 4. You'll end up with the same equation for both. Okay. This one here, it wanted us to write the equation from the table, and it asked to do it 2 different ways. So I first did it what I think is the easiest way. I found the change in my x's. I found the change in my y's. Remember, you find slope by taking the change in y over the change in x. It's always y over x, y over x. So I found my slope to be -6. So that's why -6 goes where the m is. And then b, the y-intercept. Remember, y-intercepts always have a 0 where the x is. And so I just look, and this is my y-intercept, which is a +1. So I can put +1. If I wanted to do this a second way, without the calculator, I could pick 2 points from the table to use. I just picked the first 2. And I could follow the slope formula. y2 minus y1 over x2 minus x1. Then I could pick which of these points I wanted to use, whichever one I wanted to use. I chose the -1, -7. I put it in point slope form, I worked it out, and I end up with the same answer that I did when I did it the other way. And of course, now we know we have a third way with the calculator. I can go to Stat. I can put these in list 1. I can put these in list 2. Stat again, right arrow to calculate. Go down to number 4, Lin Reg, and you can get the equation that way too. 15 wants to know, how would you use your calculator to determine if a graph matches a particular equation? I just need to put the equation into the y equals of the calculator, and then I just press graph. And I can look to see if it matches a particular equation. And if I needed to look at the table, I would hit second graph. Okay, one more page. Number 16, it asks you to write the equation. So I know this is a diagonal line, so I need to put my equation in slope-intercept form. I need to find my slope, and I need to find my y-intercept. So I look to see where my line goes through corners of boxes, and this is going by tens, so it's up 10, 20, 30. That's my rise. The x-axis is going by ones, so my run is 2. So my slope is 30 over 2, which reduces to 15, so that's what goes in front of the x. And then b is your y-intercept, and the y-intercept is where the graph touches the y-axis, which is a +20. If I wanted my calculator to help me with this, I would use the Stat button, since I brought in an equation. This is the ordered pair 0, 20, so I'd have to put 0, 20 in my calculator. And this is the ordered pair 250, and I'd have to put the ordered pair 250 in there. So the 0 and the 2 would go in list 1, and the 20 and the 50 would go in list 2. That's if you were going to use your calculator to assist you or to help you check your work. Okay, this is a scatter plot. We had a scatter plot on that last quiz we took. Didn't go so well for some of you. So remember, whenever you're writing an equation of a line of best fit, you have to use 2 points on the line. So I could have used this point, or this point. Those are my only 3 options because they're the only points on the line. I decided to use these 2 points, which I wrote down what they were over here. Since I'm given points, I know I'm going to use point slope form. I have points, but I don't have slope. So that's the first thing that I have to find. So I took y2 minus y1 over x2 minus x1. I get my slope to be a -1. Then I pick the point I want to use. It doesn't matter which one. I picked the 3220, and then I put it in point slope, and I work it out, and I get my answer. So this was like that number 4 we had on our quiz the other day. You have to use 2 points on the line. If I wanted my calculator to help me or check me, I can go to Stat, and I can put the 32 and 34 in list 1. I can put the 20 and 18 in list 2. Stat again, right arrow to calculate, down to number 4, len reg, enter, and I'll get it that way too. Okay, 18 says predict the daily high temperature if the number of pairs of skis sold is 31. Well, I know if I want to predict the temperature is the x. That's what I'm going to solve for. So the number of skis sold, 31, is the y. So all I did was I took this equation and I put a 31 where the y is. I recopy and I solve for x. So I circle everything smushed with it. I subtract what's outside of the circle. I divide both sides by -1 because that's what's in front of the x. You just don't see it. And you get 21. So it would be 21 degrees Fahrenheit. That's the prediction that we can make using our equation for our line of best fit. So you just have to know that the skis, that's your y. So the 31 goes where the y is. The next one is reverse. The next one wants to know how many skis. So this time I'm going to be solving for y, and the high temperature is 19. Well, temperature is x, so I put the 19 into the x. So I just rewrote my line of best fit equation. I put 19 where the x is, and I just work out -19 plus 52. Oh, and that's not degrees. Oops. This is the number of pairs of skis, so it would be 33 skis. And there it is. I hope you guys are fully prepared for your test. Smiley face. Thank you.